Let's take an example of a limiting reactant problem. So let's say we mix two solutions together. We mix together 25 milliliters of 0.4 molar phosphoric acid. And these are all aqueous solutions with 45 milliliters of half molar sodium hydroxide. And we might ask ourselves a question. So how many moles of sodium phosphate are formed? What's the limiting reactant? And how many moles of the limiting reactant are left? So we need to start by writing out the chemical equation. So this is a double replacement reaction. So H3PO4, NaOH. So we swap cations and anions, so the sodium pairs up with phosphate. Na3PO4, remember sodium's +1, phosphate's -3. And H plus and OH minus, oh that's good old water. And we balance it up and we'll see that it takes 3 sodium hydroxides for every 1 phosphoric acid. And like so that should be balanced. The way we handle limited reactant problems is we normally take each reactant and imagine it was completely consumed and ask ourselves how much of a common product did we make, and whatever gives us the smallest amount is the actual yield or the actual predicted amount made, and whatever would have given us a larger amount would have been the limiting reactant because it would have run out first and it was capable of making more, but there wasn't enough of the other reactant to do so. So we're going to take each one in turn and go with it. So let's take our 25 milliliters of phosphoric acid and crunch it. So 25 milliliters. We can convert milliliters to liters in order to use molarity as a conversion factor. So 0.4 molar means there's 0.4 moles in a liter. The balanced equation gives us the ratio, so there's 1 phosphoric acid to 3 sodium hydroxides, or actually let's calculate the sodium phosphate. So 1 mole to 1 mole. And that gives us a grand total of 0.01 moles sodium phosphate. We can do the same thing with the 45 mils of the sodium hydroxide. So convert to liters. Use molarity as a conversion factor. Notice 3 sodium hydroxides give us 1 sodium phosphate now. And that gives us a total of 0.00750. And those are moles of sodium phosphate. So which one, you might want to pause the video, so which one do we actually make? Which one's the limiting reactant? And the answer is we make the smaller amount. So the sodium phosphate from the sodium hydroxide is smaller than the sodium phosphate from the phosphoric acid. So that tells us that this thing over here was the limiting reactant, and the phosphoric acid must have been the excess. So how much excess did we have? Well, we can do this a number of different ways. We can sort of work backwards. We can say when we know we should be forming 0.0075 moles of sodium phosphate, so we can go from that. And go backwards. So we know for every mole that we formed of sodium phosphate, there must have been a mole of phosphoric acid. So we must have used up 0.00750 moles of phosphoric acid. And then we can ask ourselves, well, how many moles of phosphoric acid did we start with? And then the difference will be the excess. So let's scroll up. Okay. Change color. So we started with 25 mils of phosphoric acid. That is in mils in a liter. Concentration 0.4 molar. Gives us a total of 0.01 moles phosphoric acid. And then, so the leftover, or for remaining, is just the difference between those two. So we started with this much. We consumed this much. So the difference then is 0.0025 moles of phosphoric acid. So we would have had 0.00250 moles, so that's 2.5 millimoles of phosphoric acid left over.